Hello my scholars, you are welcome to my school YouTube channel and my name is Frank. In today's video we shall be tackling JAMB CBT physics past question for the year 2001. So relax, do not go anywhere and we'll be right back. You are welcome back to my school YouTube channel. In today's video, we are going to be answering question 1 to 25. So let's kick off with question 1. The height at which the atmosphere ceases to exist is about 80 kilometers. If the atmospheric pressure on the ground level is 760 millimeters of mercury, the pressure at a height of 20 kilometers above the ground level is. So let's move over to the board to provide answer to this question. So to solve this question, simply use the formula pH is equals to P naught in brackets of H minus small letter h all over H. Okay, and the pH here, represent the pressure at which we are asked to represent the height at which we are asked to calculate for the pressure, while the P naught here is the pressure at ground level. Okay, so the capital letter H here is the height at which the atmosphere ceases to exist. And the H here, the small letter H here, is the height of interest, okay, which is the one that we are asked to calculate the pressure, okay. So from the question, we are told that H is equals to 80 and 80 kilometers, and small letter H equals 20 kilometers respectively, okay. Then, so in this place, we just substitute our formula, we just substitute this value to the formula to get the answer. So here we're having 760, then in bracket 80 minus 20 all over 80, bracket close. Okay, so this will be equals to 760 times 60 all over 80. So 0 can cancel out 0 here. Okay, 2 here will give us 4, 2 here will give us 3. Okay, 4 here is 1, and 4 here will give us 190. Okay, so that will be having 190 times 3. So 190 times 3 will be equals to 570 millimeter of mercury. Okay, since we are calculating the pressure at 20 kilometers above the ground. Okay, so let's return back to the board to pick the correct answer to this question, and that is option B, 570 millimeters of mercury. Question 2. A stone of mass 1 kg is dropped from a height of 10 meters above the ground and falls freely under gravity. Its kinetic energy 5 meters above the ground is then equal to, so A, let's go through the option first. A, we have its kinetic energy on the ground. B, twice its initial potential energy. C, its initial potential energy. D, half its initial potential energy. So if we are to calculate the potential energy at the height 10 meters, okay, remember that potential energy is equals to mass times acceleration due to gravity times height, right? So based on the data that are given to us, if we multiply them together, we'll be having the potential energy at the height of 10 meters to be equals to 100 joules, right? So, and at that point, the kinetic energy is 0, okay? So, as the stone begins to fall halfway, the potential energy will be equals to 50 joules. Now, at that point also, the kinetic energy will also be equals to 50 joules, right? And this is in accordance with the principle of conservation of energy, okay? So, the total energy of the stone, okay, at that point, 50 at that point of 5 meters or halfway the fall, okay, is conserved. So that makes the kinetic energy to be equal to half of its potential energy, and that makes option D the correct answer to this question. Question 3. If a spherical metal bulb of radius 3 centimeters is fully immersed in a cylinder containing water and the water level rises by 1 centimeter, what is the radius of the cylinder? So let's move over to the board to solve this question. Now remember that when an object is fully immersed in the water, the volume of water displayed is equals to the volume of the object. Okay. Now in the case of this question, the object is immersed in a water inside the cylinder, right? So the volume of the water displaced will be equals to the volume of the cylinder. Okay. So volume of water displaced, displaced, okay, will be equals to volume of object, right? Now, the object here in question is a spherical metal bulb, right? Now, but the volume of water displayed will be determined by the vessel containing the water. So in this case, it is a cylinder. So here, the volume of cylinder is pi r square L, base area times height, okay? While here we'll be having 4/3 pi r cube, okay, which is the volume of a sphere. So pi can cancel out pi. Now remember, in this question we are told that the sphere has a radius of 3 centimeters. So you'll be having 4/3 then times 3 times 3 times 3. Okay, so 3 will cancel out 3. While here we still have our L square, but we are told that the level of water is equals to 1 centimeter. So we don't put here times 1. Right, so here we'll be having r squared to be equals to, so here we'll be having 9 times 4, so which is equals to 36, right? Now we are looking for r, which is the radius of the cylinder, so we just take the square root of both sides, so that r is equals to the square root of 36, and that will be equals to 6, okay? That will be equals to 6 centimeters. So the radius of the cylinder is equals to 6 centimeters. So let's return back to the board to pick the correct option to this question, and that is option D, 6 centimeter. Question 4. The resultant of two forces acting on an object is maximum if the angle between them is A, 45 degrees, B, 0 degree, C, 90 degrees, and D, 180 degrees. Okay, so the answer to this question is option B, 0 degree. Okay, so the resultant of two forces acting on an object is maximum if the angle between the two forces is equals to 0 degree, during which the two forces are parallel and are pointing in the same direction. Okay, so that makes option B the correct answer to this question. Question 5. The earth is not spherical but elliptical in shape. Variation in latitude and longitude. Rotation of the earth on its axis. Variation in the density of the earth. On which combination of the above does the weight of an object vary on the earth's surface? Okay, so the weight of an object vary on the earth's surface based mainly on 3 reasons. One of them is the shape of the earth. Secondly, variation in latitude and longitude. And lastly, rotation of the earth. In fact, because of the rotation of the earth, object tends to weigh more at the equator than at the poles. Okay, so based on what you have done, that means I is correct, I is correct, I is correct, and I is correct, which is 1, 2, 3 are all correct. So let's go through our option to see the one that contains I, and I, and that is option C. Question 6. The efficiency of a machine is always less than 100% because the A, work output is always greater than the work input. B, load lifted is always greater than the effort applied. C, effort applied is always greater than the load lifted. D, velocity ratio is always greater than the mechanical advantage. So one thing we must know about the efficiency of machine is that in reality, there's no machine that is 100% efficient. Okay, and this is due to reasons such as friction, deformation, and other losses. Okay, so in practical terms, the efficiency of a machine is always less than 100%, and the reason is because the mechanical advantage is always less than the velocity ratio. So in other words, we are saying that the velocity ratio is always greater than the mechanical advantage. Okay, so that makes option D the correct answer to this question. Velocity ratio is always greater than the mechanical advantage. Question 7. Which of the following consists entirely of vector quantities? So a vector quantity is one that has both magnitude and direction. So let's analyze the options one after the other. So option A, we have velocity. Velocity is a vector quantity. We have displacement, which is also a vector quantity. And we have reaction, which is a kind of force. It's also a vector quantity. So option B, we have tension, which is a vector quantity. We have magnetic flux, which is a scalar quantity, and we have mass, which is a scalar quantity. While option C, we have a displacement, which is a vector quantity. We have impulse, which is a vector quantity, and we have power, which is a scalar quantity. Then option D, we have work, which is a scalar quantity. We have pressure, a scalar quantity, and we have moment, a vector quantity. So the option that consists entirely of vector quantities is option A. Okay, so option A is the correct answer to this question. Question 8. Ice cubes are added to a glass of warm water. The glass and water are cooled by A. Conduction only, B. Convection only, C. Conduction and convection, D. Convection and radiation. So the answer to this question is option C, conduction and convection. So the glass and water are cooled by conduction and convection only. Okay, so the glass and water are cooled by conduction simply because the glass, the water, and the ice cube are all in contact. So the glass and water are cooled in that case by conduction, right? Then secondly, there is some kind of conventional heat exchange, okay, or heat transfer within the water, right? As warm water rises up and cold water flows down. Okay, so that makes option C the correct answer to this question. Question 9. A ray of light strikes a plane mirror at an angle of incidence of 35 degrees. If the mirror is rotated through 10 degrees, through what angle is the reflected ray rotated? So A, we have 70 degrees, B, 45 degrees, C, we have 25 degrees, and D, we have 20 degrees. So it is a common knowledge in physics that when a ray of light strikes a plane mirror at an angle of incidence I, and the mirror is rotated at an angle of theta, then the reflected ray will be rotated by an angle of 2 theta. Okay, so if you look at this question, we are told that the mirror is rotated through 10 degrees. Then the reflected ray will be rotated by 2 times 10 degrees. Okay, in that case, that will be equals to 20 degrees. So that makes option D the correct answer to this question. Do you know that you can take practice question with our simulated JAMB CBT past questions? All you need to do is to click on the link in the description below, and that will take you to my school website. There you have to download my school mobile app for your Android devices and my school software for your laptops and computer. Please go ahead and start practicing. Moving on to question 10. The terrestrial telescope has one extra lens more than the astronomical telescope. The extra lens is for A, improving the sharpness, B, creating an inverted image, C, magnification of the image, and D, erection of the image. So the answer to this question is option D, erection of the image. The terrestrial telescope has one extra lens, and the essence of the extra lens is to ensure that the image are erect or upright, making it easier to view objects on land. Okay, so that makes option D the correct answer to this question. I believe you are enjoying this content. If yes, please do not forget to hit the like button, click on the subscribe button, and lastly, tap on the notification bell to get informed as soon as we release the next videos. Question 11. The driving mirror of a car has a radius of curvature of 1 meter. A vehicle behind the car is 4 meters from the mirror. Find the image distance behind the mirror. So let's move to the board to provide answer to this question. So we are told that the radius of curvature R is equals to 1 meter. But remember that 2 focal lengths is equals to 1 radius of curvature, right? So in this case, we need to get the value of F first, right? So that F will be equals to radius of curvature, which is 1 divided by 2, which is equals to 0.5. Okay, so using the mirror formula, 1 over F is equals to 1 over U plus 1 over V, where V here represents the image distance, and where V here represents the image distance and U here represents the object distance. But in this question, we are told that the vehicle is behind, that is, the object is behind the mirror, right? So that our U will be equals to negative 4 meters, okay, because the object is behind the mirror, right? Now, so let's substitute these values to get what we are asked to calculate for, which is the image distance. Now, but remember that our focal length is equals to 0.5. So if we face in 1 over 0.5 here, this will be equals to 2. Okay, so here we have 2 to be equals to minus, because now we have negative 4, 1 over 4, then plus 1 over V. So we move this 4 to the other side, so that 1 over V is equals to 2 plus 1 over 4. So if we solve this, we'll be having 4 over 9. right? So we have 1 over V to be equal, sorry, we'll be having 9 over 4, okay? So our 1 over V is equals to 9 over 4. So we invert since we are looking for V, not 1 over V. So that our V is equals to 4 over 9 meters, right? So this is the image distance from the mirror. So let's return back to the screen to pick the correct answer to this question. So from our calculation, we got 4 over 9, and that makes option B the correct answer to this question. Question 12. The pressure of a given mass of a gas changes from 300 Newton per meter square to 120 Newton per meter square, while the temperature drops from 127 degrees Celsius to minus 73 degrees Celsius. The ratio of the final volume to the initial volume is, so let's return back to the board to provide answer to this question. So to solve this answer, basically, we are going to be using the general gas equation, which is P1 V1 over T1 is equals to P2 V2 all over T2. Okay, so here we are asked to calculate for the ratio of the final volume to the initial volume. So basically, let's just make that the subject of formula. So first thing first, let's cross multiply. So that will be having P1 V1 T2 to be equals to P2 V2 T1. So we want this to be at the top. So first of all, let's divide both sides by P2 by P2 T1. Okay, so if we divide there by P2 T1 and we also divide there by P2 T1, then they will cancel out. So that will be having just V here, okay, V2 here. Now, we need V1 to be under V2. So what do? We multiply both sides by 1 over V2. So if we multiply here by 1 over V2, then our V1 is out, and here we'll be having V1 under, okay? So V2 over V1 is equals to P1 T2 over P2 T1. So let's substitute, let's put in the values that are given to us. But then before we do that, we'll first of all have to convert our temperature to Kelvin, okay? So to convert this to Kelvin, what we simply do is that we add 273, okay? So if we add 273 to this temperature that is given to us in degrees Celsius, we'll be having it to be equals to 400 Kelvin. And if we add to this, we'll be having it to be equals to 200 Kelvin. Okay, so now let's substitute and get our answer. So here, our P1 is 300, then times our T2 is 200 over our P2 is 120, then times our T2 our T2. Okay, our T2 here is 200, while our T1 here is 400. Okay, so 0 will take out these two zeros, 1 0 will take out 0 here. Okay, so 2 here is 1, 2 here is 2, 2 here is 1, 2 in 30 is 15. So 3 here is 5, then 3 here is 4. Okay, so our V2 over V1 is equals to 5 over 4. Okay, so in this case, we can say that the ratio of V2 to V1, which is the final volume to the initial volume, is equals to 5:4. Okay, so let's return to the screen to pick the correct answer to this question. Okay, and that is option B, 5:4. Question 13. The thermometric substance of an absolute temperature is A, alcohol, B, mercury, C, helium, and D, platinum. So typically, the thermometric substance of an absolute thermometer, they are usually gases, such as helium or hydrogen. Okay, so that makes option C the correct answer to this question. So these gases are used because their physical properties changes predictably with temperature. Okay, so that makes option C the correct answer to this question. Question 14. A plane sound wave of frequency 85.5 Hz and velocity 342 meters per second is reflected from a vertical wall. At what distance from the wall does the wave have antinode? So let's move over to the board to solve this question. So this is a case of a standing wave that is formed as a result of reflection from a wall, right? So in this case, the wall serves as the node, okay, while the antinode will be 1/4 of the frequency of the wave. So take note of that, okay? So in this question, we know that V is equals to frequency and frequency times lambda, right? So in this case, we are looking for wavelength, which is velocity all over frequency. But we are told that velocity is equals to 342 meters per second, okay, and frequency is equals to 85.5 hertz, right? So let's substitute these values into the formula. So lambda is equals to 342 divided by 85.5. Okay, so if we divide this, that will be equals to 4 meters. Now remember that lambda is measured in meters, so it equals to 4 meters. But here we are asked to calculate for that what is the distance from the wall does the wave have antinode. What distance from the wall does the wave have antinode? Now, like I said earlier on, I said the wall itself serves as the node, while the first antinode will occur 1/4 of the wavelength, okay, of the wave. So in this case, the distance will now be equals to 1/4 times that of 4. Okay, so if we divide, that will be equals to 1 meters. Okay, so the wave will have an antinode at a distance of 1 meter from the wall. Okay, so let's return back to the screen to pick the correct answer to this question, and that is option C, 1 meter. Question 15. A string is fastened tightly between two walls 24 centimeters apart. The wavelength of the second overtone is, so let's move to the board to provide answer to this question. So when a spring is fastened at both ends, the formula for calculating the wavelength of the wave is given as lambda is equals to 2L all over N. Okay, where L stands for the length, okay, where it stands for the length of the string, and N stands for harmonics. Okay, harmonics number. Now remember here we are talking about second overtone. Okay, so for second overtone, N is equals to 3. Okay, for second overtone, N is equals to 3. So let's just substitute the values that are given to us to get the answer to this question. So this will be 2 times 24, because the length of the string equals to 24, then over 3, because we are talking about second overtone. So for second overtone, N is equals to 3. Okay, and remember that N here represents the harmonics number. So here we have 3. So 3 here is 1, 3 here is 8. So 2 times 8 is equals to 16 centimeters. So let's return back to the screen to pick the correct answer to this question, and that is option B, 16 centimeters. Question 16. A gas with initial volume of 2 times 10 raised to power minus 6 meter cube is allowed to expand to 6 times its initial value at constant pressure of 2 times 10 raised to power 5 Newton per meter squared. The work done is, so let's move over to the board to provide answer to this question. So the formula for calculating the work done by the expansion of a gas at constant pressure is given as W is equals to P then delta V, where delta V represents change in volume. Okay, so from the question, we were told that V has this value, and V2, which is the final volume, is times 6, is equal to times 6 of the initial volume. So since the initial volume is 2 times 10 raised to power minus 6, then the final volume will be 6 times 2 times 10 raised to power minus 6. So that will be 12 times 10 raised to power minus 6 meter cube. Okay, so let's just substitute this into our formula and get our final answer. So W is equals to 2 times 10 raised to power 5, then times bracket open. So you'll be having 12 times 10 raised to power minus 6, then minus 2 times 10 raised to power minus 6, all in bracket. Okay, so here I'll be having 2 times 10 raised to power 5, then if we subtract, you'll be having times 10, okay, times 10 raised to power minus 6. So if we multiply these two, that will be equals to 20, right? If we apply the law of indices here, we'll be having times 10 raised to power minus 1. Okay, so minus 1 simply means that you move the decimal place just one time to your left. Okay, so if I move it at the end of that, I'll be having my answer to equals to 2.0 joules since we are calculating for work done. Okay, so let's return back to the screen to pick the correct answer to this question, and that is option A, 2.0 joules. Question 17. A cell of internal resistance R supplies current to a 6.0 ohms resistor and its efficiency is 75%. Find the value of R. So the small letter R represents the internal resistance. Okay, so let's move over to the board to provide answer to this question. So the efficiency of a cell, okay, the efficiency of a cell is given as R all over R plus small letter r times 100, okay, over 1. Now, our area is the external resistance, okay, it's the external resistance, while small area is the internal resistance. But remember, in this question, we're told that efficiency is equals to 75%, right, which is the same thing as 0.75. So, and we are told that R is equals to 6.0 ohms, which is the external resistance. So let's substitute it into this formula. So that we'll be having 0.75 is equals to 6.0 all over 6.0 plus R. Okay, so if we cross multiply, we're having 0.75 bracket open 6 plus R is equals to 6. So we open up the bracket by using what we have outside to multiply everything we have inside. So 0.75 times 6, that would be equals to 4.5, then plus 0.75 R is equals to 6. So here we simply collect like terms, so that 0.75 R is equals to, so if we subtract, this 4.5 will move to the other side, so that we'll be having 6 minus 4.5. And that will be equals to 1.5, right? Now, since we are looking for R, we divide both sides by the coefficient of R, which is 1.5 will be divided by 0.75. Okay, so to make this easier for us, 1.5 is the same thing as, say, 15 over 10, right? So 0.75 is the same thing as 75 over 100. So we just invert, right? So if we invert, we'll be having 100 here, while here we'll be having 75. Okay, so this we take out this, so that here we still have 10. So here we'll be having 150 divided by 75, and that will be equals to 2 ohms. Okay, so the value of the internal resistance is equals to 2 ohms. So let's return back to the screen to pick the correct answer to this question, and that is option D, 2.0 ohms. Question 18. A resistance R is connected across the terminal of an electric cell of internal resistance 2 ohms, and the voltage was reduced to 3 over 5 of its nominal value. The value of R is, so let's move over to the board to provide answer to this question. So from Ohm's law, we know that I, current, is equals to V all over R, right? And remember that current also is also given as E, okay, over R plus small letter r, where small letter r here represents internal resistance, and big R here represents external resistance. So the E here is the nominal value of the voltage that you are referring to in this question. So first of all, from here, let's get the value of E, right? So V is equals to 3 over 5E, right? And R we don't know. So let's put in this. Here we'll be having 3E all over 5, right? Divided by R, which is this, divided by R, right? So if we decide to change this, we'll be having 3E all over 5 times 1 over R, so that our current I is equals to 3E all over 5R. Okay, now let's return back to this place. Now our nominal value here is equals to E, so we leave it, right? And our arrow we don't know, then we have plus the internal resistance, which is given to us to be equals to 2 ohms. So we put 2 here. Now we'll be equating both equations. So let's go to equation 1, okay? Let's go to 1, let's go to 2. So in this case, we are going to be equating both equations. So that we'll be having 3E all over 5R to be equals to E all over R plus 2. So we just cross multiply. So that we'll be having 5RE to be equals to, so if we multiply here, we'll be having 3RE then plus 6E right? So we can collect like terms so that 3 arrow E moves down to this side. So that we'll be having 5 arrow E minus 3 arrow E to be equals to 6E. So what is common here? Okay, so if we subtract, we'll be having 2 arrow E, which is equals to 6E. So there is E here and there is E here, so they'll cancel out, right? Now we are looking for R, so we just divide both sides by the coefficient of R, which is 2. So that R is equals to 6 divided by 2, that is equals to 3 ohms. Okay, so let's return back to the screen to pick the correct answer to this question, and that is option A, 3 ohms. The value of R is 3 ohms. Question 19. A student is at a height 4 meters above the ground during a thunderstorm. Given that the potential difference between the thunder cloud and the ground is 10 raised to the power 7 volts, the electric field created by the storm is, so let's move over to the board to provide answer to this question. So electric field intensity can also be calculated using the formula V all over D. Okay, so in this question, D is given to us to be equals to 4 meters and V is given to us to be equals to 10 raised to the power 7. So this 10 raised to the power 7 is still equal to 1 times 10 raised to the power 7. I think it doesn't change anything. If you multiply 1 by any value, that value still remains the same. Okay, so 1 times 10 raised to the power 7 all over 4. So let's divide. So let's just rewrite this. 1 over 4 times 10 raised to the power 7. So that 1 over 4 is equals to 0.25 times 10 raised to the power 7. So let's put this in standard form because this is not in standard form. So we just move 1. So here we'll be having 2.5 times 10 raised to the power. Now since we moved from our left to our right, we are going to subtract 1 from the power of 10. Okay, so that we'll be having 6, right? But we are asked to calculate for electric field. We are asked to calculate for electric field intensity. Okay, so electric field is given, the unit is Newton per coulomb. Okay, so our final answer is 2.5 times 10 raised to the power 6 Newton per coulomb. So let's turn back to the screen to pick the correct answer to this question, and that makes option B the correct answer to this question. 2.5 times 10 raised to the power 6 Newton per coulomb. Do you have any question to ask? Please feel free to ask all your questions by simply clicking on the link in the description below, and that will take you to my school website. There you can ask all your questions, and our team of solution provider will provide answers to all your questions within a short period of time. Moving on to question 20. A working electric motor takes a current of 1.5 amperes when the potential difference across it is 250 volts. If its efficiency is 80%, the power output is, so let's move over to the board to provide answer to this question. So electrical efficiency, okay, so efficiency is equals to power output all over power input, okay, over power input times 100 over 1. But if you look at this question carefully, we are not given power input. But remember that power input is equals to IV, right? So we are giving current and we are giving voltage. So that power input IV is equals to 1.5 times 250. So let's leave it there. So let us substitute. Now remember, we are given efficiency to be equals to 80%, and 80% means 80 over 100. So we have 80 all over 100 is equals to power output, which is what we are looking for. Then here we have 1.5 times 250, which represents the value of the power input. So we just cross multiply so that power output in this case will now be equals to 80 times 1.5 times 250 divided by 100. Okay, so these two zeros will take each other out, so that we'll be having 80 times 3 over 2 times 25. Okay, so 2 here is 1, 2 here is 4. So we have 12 times 25, and that will be equals to 300 watts. Okay, so let's return back to the screen to pick the correct answer to this question. So from our calculation, the power output is equals to 300 watts, and that makes option A the correct answer to this question. Do you have better explanation or solution to any of these questions? Please do not keep this to yourself, but reach down to the comment section below to comment the question number and the solution you wish to share. Question 21. The cost of running 560 watts lamps and 400 watts lamps for 20 hours if electrical energy costs 10 naira per kilowatt hour is. So let's return back to the board to provide answer to this question. So basically, know that energy consumption, okay, so energy consumed is equals to power times time. Okay, so here first of all, of course, the power must be in kilowatts, okay, not just in watt. But first of all, let's get the power consumed. So the total power consumed by the household in this case will be equals to, let's say P total will be equals to 5 times 60, then plus 4 times 100. So this is 300, and this will be equals to 400. So if we add it together, that will be equals to 700 watts, okay? But remember, the power must be in kilowatts, so we just divide this by 1000 to convert it to kilowatts. So if we divide by 1000, we have this 0.7 kilowatts, okay? So now we can calculate for the energy consumed, okay? So in this case, the energy consumed equals to 0.7 times, of course, the time is 20 hours, so here we have 20, and that will be equals to 1.4, okay? That will be equals to 1.4, no, that will be equals to 14, okay? That will be equals to 14 kilowatts per hour, okay? But remember that we are told that 1 kilowatt per hour costs 10 naira, okay? So how much with 14 kilowatts per hour cost? So in that case, 14 kilowatts per hour will now cost 14 times 100. Okay, sorry, 14 times 10, and that will be equals to 114 naira. Okay, so let's return back to the screen to pick the correct answer to this question, and that is option D, 140 naira. Question 22. In a Daniel cell, the depolarizer, positive and negative electrodes are respectively A, copper sulfate, copper and zinc, B, magnesium dioxide, carbon and zinc, C, sulfuric acid, lead oxide and lead, D, potassium hydroxide, nickel and iron. So in a typical Daniel cell, the depolarizer is actually copper 2-tetrasulfate 6 solution, also known as copper sulfate, okay? While the positive electrode is the copper container and the negative electrode is the zinc rod, okay? So option C here typically describes a lead acid accumulator, which is your car battery, okay? So, but for Daniel cell, okay, but for Daniel cell, the depolarizer is copper sulfate, while the positive electrode is copper and the negative electrode is your zinc, okay? So that makes option A the correct answer to this question. Question 23. When a piece of rectangular glass block is inserted between two parallel capacitors at constant plate area and distance of separation, the capacitance of the capacitor will A, increase, B, decrease, C, decrease, then increase, D, remain constant. Okay, so we know that the capacitance of a capacitor C is given as epsilon naught area divided by D, okay, where C here is the capacitance, E here is the dielectric constant, while area refers to the area of the plate, while D is the distance of separation between the plates. So from here you can see that the capacitance of a capacitor is directly proportional to the dielectric constant, meaning that as the dielectric constant increases, the capacitance of the capacitor will also increase. Okay, so in this case, a rectangular glass block is inserted between two parallel capacitors. Okay, now one thing you must take note of is that the dielectric constant of a glass is greater than that of air. Okay, that of air is approximately equal to 1, but that of glass is greater than 1. So since we are increasing the dielectric constant, right, we inserted a material that has a greater dielectric constant than that of air. What that means is that the capacitance of the capacitor is going to increase because of increase in the value of the dielectric constant of glass block. Okay, so that makes option A the correct answer to this question. Question 24. The ratio of electrostatic force Fe to gravitational force Fg between two protons, each of charge E and mass m at a distance d is. So let's move to the board to provide answer to this question. So we are actually looking for the ratio of Fe to that of Fg, right? But Fe is given as E squared because we are asked to take it as E, okay? E squared all over 4 pi epsilon naught, okay? Epsilon naught d squared. And that of Fg, which is gravitational force, is given as, g m squared all over d squared. Okay, so since we are looking for ratio, that is, we are having Fe all over Fg. And here we'll be having e raised to power 2 all over 4 pi epsilon naught d squared, right? Then divided by this. So I will just invert, so that we'll be having times d squared all over gm squared. So here d squared, we cancel out d squared, so that the ratio of Fe to that of Fg is now equals to E squared all over 4 pi epsilon naught gm squared. Okay, so let's return back to the board to pick the correct option to this question. Okay, so what we got on the board there is E squared all over 4 pi E naught gm squared, and that makes option D the correct answer to this question. Question 25. A cell can supply current of 0.4 ampere and 0.2 ampere through a 4.0 ohms and 10.0 ohms resistors respectively. This internal resistance of the cell is. So let's move over to the board to provide answer to this question. So remember that the nominal value of voltage E is given as I, then bracket open R plus small letter r, where capital letter R here represent external resistance and small letter r here represent internal resistance. Okay, while I here represent current. So in this question, we are given two currents and we are given two external resistance that we should calculate for the internal resistance. Okay, so in this case, let's just substitute. So our E is equals to 0.4 bracket open. In that case, we're using 4, then plus R. We don't know. So let's call this equation 1. Okay, let's just open the bracket. So if we multiply here, we'll be having 1.6, then plus 0.4 R. So let's call this equation 1. Okay, let me remove this. Let's call this equation 1. Now let's do it for the second value of current and external resistance. So we'll be having I, which is 0.2 bracket open, then here is 10, then plus R. Okay, so let's open the bracket, then we'll now call it equation 2. So 0.2 times 10, that equals to 2, then plus 0.2 R. So let's call this equation 2. So we can now equate equation 1 and equation 2 because of the nominal value of the voltage. Okay, so here we'll be having 1.6 plus 0.4 R to be equals to 2 plus 0.2 R, right? So the next is just to collect like terms. So if we collect like terms, I'm going to move this to this side. So I'll be having 0.4 R minus 0.2 R to be equals to 2 minus 1.6. So if we subtract here, we'll be having 0.2 R, and here we'll be having 0.4. Okay, so since we are looking for the value of R, we divide both sides by the coefficient of R, which is 0.2. So R is equals to 0.4 divided by 0.2. Okay, and this will be equals to 2 ohms. Okay, but we can solve it like this: 4 over 10, then we invert. Okay, so here we'll be having 10 over 2. So 10 we cancel out 10, so that 4 divided by 2, that will also give us 2. So whichever way you want to go about it, you will still be correct. Okay, so let's return back to the screen to pick the correct answer to this question, and that is option A, 2.0 ohms. I believe you enjoyed this video content. If yes, please do not forget to hit the like button, click on the subscribe button, and lastly, tap on the notification bell to get informed as soon as we release the next video.